Here we can practice 8 to 1 multiplexer simulation using our Cartus Prime software. Open this software, new project wizard. Next option, here you can create one folder for your program file. So I'm going to create one new folder and you can assign any user defined name for your folder. I'm going to give this name as Multiplexer for this folder and select the folder. Then you have to set name for your project file. So I'm giving this name as Mux. Next again, here you have to specify the file name. This file name should be the same name of your project. So keep this file name as Mux. Next, in this board option, you have to choose this DEO CV develop option and click next. Here in the simulation, you have to choose this model simulation Altera. Then next. Finish this operation. So now we can choose a new empty file for creating our multiplexer program. So choose from the file a new option in this Verilog HDL file. Okay. So here you can write your program code. So I have my program code here. So this is the program. Here for the module name, this name should be the same name of your file. Always keep the module name as your file name. Okay, then we can save this. See, the file name is Mux itself. Now this is that 8 to 1 multiplexer simulation code. Then now we can choose here files and right click on this. Here you can see your file Mux here. So right click and set it as top level entity. Then you can go for the compilation. Here you have this compilation option, start compilation. Here it is the progress part that's showing the progress of your compilation. See that compilation is done. Here you can see it is showing that 100%. Now we can go for this tools, and in this tool you have to choose this run simulation tool, in which RTL simulation. See, one new window will open now. Click on that new window. And here go to this RTL work, click on this plus symbol. See, your file is here, available here. Then right click on your file name and choose this create wave. See, your input and output variables are now listed here. I indicate inputs, array input and selection line inputs. This is also a 3 entry array. Then Y is that output. From this list, you have to keep all the input variables here and you have to delete output variable. Here we have only one output variable, that is Y. You have to delete this. For that, right click on this output variable, choose this edit option, then delete. Then Now you have removed that output variable. Now you can simulate your file. Go here in this, under this RTL work, right click on your file and simulate option. So here an extra list of input and output variables are listed here now. So from this you can drag this output variable, only that output variable, and you can drop here under this list. Now you need to initialize your inputs and inputs. Okay, so first you can initialize array I. So right click over this edit option, wave editor, create and modify waveform, and thus here you need to keep this option as, under this patterns you have to keep this option as counter for multiplexer implementation. Next option, and keep this initial value 0, keep this time period as 50, then we can finish this. Again for the select line, repeat the same, edit option, wave editor and create and modify wave, counter option again. Next, initial value keep it as 0, here already it is 0 in 3-bit. It's fine, and now we can change that, we can assign some other clock period other than that input, then finish. So after initializing this input variables, now we can go for that run all option. It will generate a new output wave Y. Now click on this input variables. Here it listed all that input variables or different entries of your input array 0, 1, 2, 3, 5, 6. Okay. Then here that's 3 selection lines S2, S1, S0. Now we can fix one location here, and thus a waveform. See, and thus now that S2, S1, S0 is of the form 101. 101 means 5. What is IO5? IO5 here it is 0. So that 0 is now assigned to your output Y. That is, see, here it is 0. Now we can move this and we can place somewhere else. Now see that selection line value is of the form 110. 110 means 6. So in this I6 the output is 0. So here see the output Y is assigned with the value of I6, that is 0. We can move to somewhere. See here your selection line is of the form 0, 0, 0, that is S of 0. 0, 0, 0 means 0th input, that is this one. See here that value is 1. That one is transferred to final output Y. So this is that output pattern.